And the agenda for today's meeting is as follows. First, we will have an introduction for our project coordinator, Professor Christoph Green, for the University of Kaiserslautern. After this, Tanasi Triferidis from CERN is going to provide us an overview of the vicinity pilot sites. After this, Victor Oravec from Wavener is going to provide a technical overview. And Maria Coatley from CERN is going to explain us how to create a service. After this, I will provide you a presentation about the participation rules. Please remind that the questions will be answered after each presentation. If you have any doubt, please use a Slido to ask the question. Thank you very much. And Christoph, the floor is yours. In the meantime, I'm going to provide you questions in the Slido tool. Thank you.
So, welcome everybody. You should see my screen now with my presentation. In the presentation, I will give a very broad overview about or on Vicinity, in particular its objectives, and let's say the basic things that you need to know. We give more details later on. First of all, I remind you slido.com to ask questions. Vicinity, for your information, is an ICT 30 project. Maybe some of you know the other ICT 30 projects or have participated in calls there. The call targets the interoperability in the Internet of Things. And of course, so does Vicinity as well. It is a research and innovation action with 7 million euro funding from the European Union. We are among the larger ICT 30 projects together with Big IoT. We have 15 partners from mostly all over the European Union, in particular from Spain, from Greece, and also a lot of partners from other countries. The duration of the project is from January 2016 until the end of these years. So in difference to the other ICT 30 projects, we are a 4-year project, and hence we have now our open call when the other ICT 30 projects are already finished. As already mentioned, we have 2 open calls with costs of up to, together, 500,000 euro. The first open call is already started, so you cannot apply there anymore, but we have opened the second open call and you are here in the right webinar to get into that. For your information, in the first open call we had 42 submissions, from which we selected in the end 4. The Vicinity objective is to create an IoT platform that specifically addresses the following topics. First of all, interoperability at semantic level across silos of so far incompatible devices is targeted. I think this is similar for all the ICT 30 projects. The more specific and particular issues that Vicinity targets is privacy. And we do this by implementing a peer-to-peer approach. Overall, Vicinity is an open, free, decentralized, and user-driven approach. That means there are no particular license fees needed. It is specifically made to support SME and public organizations that strive to have high privacy. The concept and the architecture that will be explained later in more detail underline these unique selling points. There is a central Vicinity platform that provides us with the identities of users and connections, but it does not implement any services. It does not store any data beyond, let's say, the identities of the users and maybe their connections to friends, but no data beyond that. Value-added services are implemented by third parties, for example, by you, the participants, on separate infrastructures or on shared infrastructures among different parties. As already mentioned, Vicinity is a peer-to-peer approach. Users share their data or their devices only with the services or, let's say, friends, partners that they use and that they trust. There is no sharing of data beyond that. This is a quick overview of what I explained. The idea is to have a Vicinity IoT platform gateway that in the end acts as a registry of the users and for device management, for example, but that does not get the data. The data are communicated among the objects and the value-added services. We are now mostly progressed. As mentioned, we are in the final year of Vicinity, and we are now having opened the last open call that deals with the value-added services. I think you know all that. The idea of the open calls and the cascaded funding scheme is that projects like Vicinity reserve some resources for partners that join the consortium, Vicinity, after it is granted for open call projects. Usually this amount of money is a small amount of money compared with the other funding. Concretely for Vicinity, we have reserved 2 times 250,000 euro for the 2 open calls, and we expect that the projects get a funding of up to 60,000 euro per new partner in 6 months. The first open call has targeted new infrastructures. That means objects at the leaves of the network. Yeah. The call is finished or is running. In the end, it's implemented. You can no longer join. 4 projects are running. The second open call is open now. Yeah, you are here. That's good. And it targets not the infrastructures anymore. It focuses more on the value-added services that contribute to concrete use cases, and that in particular shall contribute to the dissemination, exploitation, and the impact of Vicinity. This also is underlined by the evaluation criteria, where Carmen will later tell you a little bit about it. As a second, let's say, way to contribute are so-called microservices that do rather internal services that are used in arbitrary value-added services as, let's say, some internal service. That can be, for example, the integration of some other, let's say, softwares or services, how to join them. It can be, for example, smart contracts or something like that, whatever is on your mind. We have a list of some ideas later on as well. Note that it is in the end driven by the needs of our use cases. We will report on the use cases to you as well in a later presentation. So far, thank you. I refer in many details also to later presentations on the use cases, on the on Carmen's information on the call details, and of course on the presentation on how to implement such a value-added services. Many thanks. Carmen?
Thank you, Christoph. I am going to check if there is any question. I don't see any question there. Okay, we can go for the Hello, I don't see any questions right now in the Slido tool. We can go for Tanasis presentation regarding the pilot site. Please remind that the questions should be asked using Slido. Thank you. I think Thanasis is here.
Okay, you can hear me, right?
Yes.
Okay, so hello everybody. My name is Thanasis Theodoridis. I'm from CERF, a research institute in Greece. So I'm the technical manager of the project, and I'm here to present an overview of the pilot sites and also some indicative value-added services that could be in interest for you to develop on top of what we have already created, or as already mentioned by our project coordinator, around microservices that could be up to you to decide how to actually contribute. So I'm going to be giving you an overview of the 4 project pilot sites that we have already realized here in the project. So we are covering 4 different domains in 3 different countries. We have a demonstrator on e-health domain that is hosted in Pylea Hortiatis in Greece. We have one in Portugal, in Martin Longo, that's around smart energy and buildings. We have another demonstrator on smart building, which is located in a building in Oslo, in Norway. And finally, we have a smart parking installation in Tromsø, Norway, where we are presenting also, apart from what you can see from the specific domains, we are also targeting some cross-domain applications in the project. So I'm going to be giving a quick overview around each of the pilot sites that we have already implemented, and mainly I will be focusing on the use cases that we have already realized per pilot site and also the available IoT infrastructure. And based on this is where we are asking for you to identify where you could actually contribute on top of what we have already implemented, on top of the available infrastructure and the available data. And we are giving you here some ideas on the value-added service that you could actually implement through the funding that you can receive through the second open call of the project. And as a second point, we also have identified an indicative list of microservices for the second open call. This is, as we mentioned, an indicative list. So therefore, it's just to provide you some ideas of how and what you could actually bring forward through this open call. And of course, this is not a short list. You can extend if you think that you can somehow also provide something more for the project. So starting from the first pilot site, which is the e-health demonstrator in Greece, in Pylea Hortiatis. This is around e-health and assisted living, and also some fitness and preventive medicine use cases that we have implemented here in Greece. The first use case is around assisted living, and it provides assisted living services for remote monitoring for elderly people. So this is something that we have implemented, and we have distributed IoT devices coming from both medical devices such as sensors that are monitoring like pressure sensor or some communication sensors. And also we have a cross-domain application with building sensors that allow us to control and to monitor the conditions within the house. So the offered services currently have to do with GDPR regulation service that we have implemented. Through this, all the processing and storing of the medical data happen. We further have developed some value-added service around the analysis of the medical data regarding, for example, the frequency and the type of measurements, in order to provide some alerts based on outliers that can be identified based on the raw data. And also, we have made an integration with the available building sensors in some of the buildings, based on which we are able to detect abnormal conditions and therefore raise some events to respective either doctors or relatives that are around the elderly people and are supporting them through their living. And you can, we have also developed some applications that are used in order to be able to provide the outputs of the value of the services, and through this reach our end users. The second use case is around e-health urban marathon. So this is a use case which aims to promote healthier lifestyle to the middle-aged citizens, which is something like a fitness competition, let's say, where we are aiming through some IoT devices like fitness trackers and some beacons that are deployed in some gyms around the municipality. We are using, I guess, a GDPR service for storing and accessing these data to prevent and to support all the regulations that are opposed by the GDPR. And we have implemented as a service, as a value-added service, and a mechanism, an awarding and a gamification point system based on the data that we collect from the different participants, the different end users. We apply and we provide games, let's say point games, in order to host this kind of competition between the participants. And we are further providing, based on the data collected, some aggregated analysis of the medical data collected and the activity data, providing some overview to the municipality on the status of the population's activity and how this actually evolves over time. So coming to the part that involves you, so we have identified here some indicative services that could be an extension, let's say, to what we have already built through the course of the project. So, for example, you could build a service that would allow the analysis of the data in real time, for example, based on the data that are coming from fitness trackers or the beacons that are located in the sports centers and in the gym. Another could be in the monitoring of the medical treatment plans that are based on what the doctors provide in the different users, and this could be based on the use of some more efficient and more high-end, let's say, IoT equipment. For example, we could use some smart drug dispensers that we can monitor actually how the users take their prescriptions, or to use Amazon Dash buttons that are used to provide how they actually utilize some of their medication or whatever it is that is prescribed to do in the house. And also another could be in detecting social difficulties of the elderly people, again, via either the already implemented or some more IoT devices and creating some psychological profiles or whatever else you could think of. So proceeding to the second use case, which is around the second pilot site, which is around smart energy and buildings, which is located in Portugal, in Martim Logo. Here we have some demonstrations around the solar platform and the solar lab that is located there, and some around the municipal building clusters in this area. So the first use case is facilitates dynamic data collection from various sources, including sensors and other cloud services, in order to offer a dynamic building audit from the energy and the environmental sensors, and allow the real-time monitoring of these buildings that you can see in the picture from different municipal cluster of buildings in the area. And this is utilized on top of a range of different IoT infrastructure and sensors that are measuring in real time temperatures, humidity, CO2 emissions, electrical consumption, and some other measurements like water pulse count and single-phase counters. The second use case is aims to demonstrate the reuse of existing equipment from local services through the Vicinity platform. So the offered services here are around the monitoring of the ultraviolet radiation index, in order to provide some indications and some warnings also to the end users that could be children, tourists, or elders in the area, to prevent from harmful effects of this solar radiation. And the IoT infrastructure used in this case, and that has been integrated in the Vicinity system, is the KNZ UV sensor that you also see in the picture here. And the third use case is on distributed energy assets management. So by monitoring the meteorological conditions in the area, we can have more accurate prediction and scheduling of such actions like washing of the solar PV panels, for example, in order to optimize the resources and the equipment that is needed in this case. So the service that has been built and offered is on a smart clinic of PV panels, where we have the operational management for distributed renewable production resources in an optimized manner provided to the stakeholders that are involved in this process. And again, here we can see a list of some indicative services that could be used in these cross-domain services for energy. For example, you could provide something on the prediction of the renewable energy production, for example, through solar irradiance measurements in above services, or to consider how we could actually involve the energy market in some cases based on the price signals that are received and offer something that is more dynamic, let's say, and optimized in order to be to better address this dynamic of the energy market. Or further provide an analysis of the energy savings and how they impact based on the services that I just presented in this case. The third use case is around smart buildings, which is located in Oslo pilot site. So the first use case here is around predictive operations that are dealing with cleaning staff and how, based on the data received from the room usage, like occupancy and door sensors, we can provide some notifications when actually the rooms are needed to be cleaned. So the service that we have created are around cleaning and waste removal notification service, which addresses the cleaning staff and optimizes how they actually perform and organize their day-to-day maintenance of the different rooms in the building. And the second use case is using and utilizing the resource management. So in this case, we are supporting the decision-making of the energy management with appliances control. This is combined with a weather forecast service, and in order to predict upcoming electricity peak loads based on the estimated needs for additional heating or cooling in the premises of the building. And the services that have been implemented in this case are around management and prediction of the energy consumption in the building. So here in the building automation domain, some indicative services that could be built on top of the Oslo pilot case could be, for example, on the capturing of the subjective experience of a room's indoor climate conditions and the cleanliness status in order to properly plan the climatization and cleaning. This could also be further using occupancy information from the room. Also, another option could be the use of building information modeling techniques and models to see how they can also be integrated with dynamic data coming from the sensors in order to provide a better dynamic audit around these services. So finally, the fourth use case of the project is around smart parking. This is located in Norway, again on Tromsø. Here, what we have built is a case where we are offering shared parking and priority parking use cases on a specific cluster of buildings. So we have implemented a smart, let's say, ticketing service, which is offered to the parking space owners and the vehicles users by utilizing IoT infrastructure like parking sensors and smart lights for the indication of the availability of the different parking spaces. And in this case, we offer services based on the priorities that different end users have and allow this implementation through specific applications, mobile applications that we have built for the project. And the second case is a cross-domain one, which is further offering services, parking services in case of any health emergency. So in this case, in case of an emergency where, for example, a caretaker needs to find quickly a location, a parking spot to provide some services, then here we have implemented a value-added service that actually takes into account this emergency and changes the way it actually provides the parking availability based on these demands. So here is another list of indicative services in the smart parking domain that could be leveraged on top of the Tromsø pilot case. So this could be solutions for the integration of smart parking with other transport-related sectors, or integration with EV charging stations, for example, to offer smart parking solutions also around this type of vehicles, including, for example, the consideration of current status and the technical information provided by the car itself. Smart transactions and rental modules for vehicles and parking space could also be considered. Also, on top of the already available infrastructure, we could foresee the implementation of a smart booking system service that could also, for example, be integrated with personal information manager like Outlook or something similar. So moving to the last slide of my presentation, as we mentioned, apart from what you can actually build on top of the already available pilot sites and IoT infrastructure and data collected in the 4 pilot sites, we are further inviting you to build and to create and to demonstrate new microservices, new value-added services that, and here is an indicative list just to mention some of these. So, for example, one could be a framework that provides incentive mechanism or micropayments, for example, by using smart contracts. Another could be a framework that makes the development of interactive applications on top of what we have created as the Vicinity platform for a more efficient and easy way, for example, for integration of software components that could provide services like analysis, visualization of data provided by Vicinity, or to allow end users to easier interact with this data. Integration and provision of information through personal information managers like Outlook, for example. And another interesting point would be the integration and the co-creation with some of the already established and available social network platforms such as My Data or DigiMe. So, as I said, this is just an indicative list, just to show you towards where you could be heading in order to build on top of what a Vicinity platform has to offer. And please be free to make any questions or clarifications if you may need. Thank you for your attention.
Okay, Thanasis, there is a lot of questions right now. I think we are going to answer this question in an order way, okay? We can start for the first question. We have is from Adam Kapala, and he say, how far do you go with the Word3 platform? Does that mean that I, as provider of added value services, will not pay a fee for my service connected? Okay, thank you for your question, Adam. The idea is that Vicinity is an open source platform for the open call participants. The connection of the value-added services are free, of course, during the duration of the project. But if you are going to provide data to the platform, you can obtain free services. But if you want to commercialize services using the platform, you have to explore some fees with probably Babinir, the one who is going to exploit the platform, depend on the kind of project you are talking about. But this is the idea. Okay. For the following question, what is the proposed time frame? I will answer this question in my presentation. We have another question that says, on use case 1, are you currently doing fall detection of the elderly carrying the panic button?
Okay, so maybe I will answer this question. So the panic buttons that we are currently utilize have a fall detector, so they are integrated in this wearable panic button. And once actually a fall is detected, a signal is sent through a communication device that is installed in the elderly house, which allows the external call center that supports the elders to actually take an action by making a call directly to the house, or if there is no reaction from the elder, to actually proceed to the next step, that is actually calling an ambulance to the person's house. So yes, fall detection is already implemented.
Okay, thank you, Thanasis. For the following question, from the guide template, your proposal should be based on one or more services from the list. You mentioned that these are indicative. Can you clarify, please? You should select one service from the list, and I will explain you this further in my presentation. Okay, but you have to select one for sure, and you have to select between topic A, value-added services, or topic B, microservices. But I will come back to this in my presentation. Co-creation is mentioned with external communities. This is the following question. Co-creation is mentioned with external communities for which support letters should be provided. Is that obligatory or mandatory? As far as you want to have better marks, I kindly recommend you include support letters, but it doesn't mean that these external communities are going to participate in the project, but it means that you have a backup community back you. Okay? For the following question is about, do you have any test site for public transportation use cases? Someone who want to answer this question?
Yes, I can give an answer here. Actually, we have no direct inclusion of public transportation. However, if I look at our use case sites in Norway, Tromsø, that might be relevant to the use case site in Tromsø. Yeah.
Okay, and we have the following one. What is the difference between microservices and value-added services?
I can answer that. Value-added services address in the end users, or have a more complete, let's say, set of users. You can really see them as a user. Microservices are, let's say, services that can be used by any other service, by machines in particular, but not necessarily by end users. It could be, for example, visualization could be a value-added. Visualization is in between, yeah. Yeah. There is no absolutely sharp boundary between both. I think visualization or data analytics is in between. Yeah, I would say data analytics is rather a microservice. Yeah, as it is not really providing a complete service by its own. Yeah, I would define it as a value-added service. Provides a service of its own, independent from let's say additional inputs to the end user.
And the last one is regarding the. I think it's said that if the microservice should reside in the IoT gateway. I don't see the question right now.
Yes, I didn't see it. Yes, where the microservices reside. I would leave it in a separate, let's say, a separate computer. It's in the end, technically, I would see it as something that is very similar to a real service, but it provides outputs, as it were, for example, a sensor, or it can provide output to a screen. I would see it as separate from the VICINITY IoT gateway. Yeah. It is not necessarily part of the IoT gateway. No, it's separate.
Okay, I think all the questions are answered as the time frame, but I am going to explain this in my presentation. If you can, if you don't have any objection, we will go for the following presentation, the technical presentation from Victor Oravec, and he's going to provide more knowledge about the technical information about Vicinity.
Okay, I hope you can hear me and you can see my presentation. Sorry for that. So my name is Victor Oravets. Sorry. My name is Victor Oravets, and I was responsible for the architecture of the Vicinity, and still is. And as well, I'm leading the implementation of the core components of the Vicinity, with which you will interact when you will implement the value-added service. So before we go, so we have already a small understanding what is the open call about. Then we already had a presentation about the pilot site. So what we are looking for in terms of the value-added services. And now I would like to give you a short example or explanation of the concepts of the Vicinity. So in that can when you start to dig in the technical documentation of the project, you will be able to more quickly grasp the idea of what is expecting from the implementation or from the technical design which you need to provide anyway. So for the first, we are providing a Vicinity peer-to-peer interoperability concept. And what does it mean? What does it mean? We came with a nice concept of the interoperable. The problem at the beginning is always that everything in IoT mostly right now is in a silo problem. So we have a silos for intelligent building management. We have a silos for energy ecosystem. We have silos for public transport, etc. And the idea of the whole IoT as an Internet of Things or Internet of Everything is to have everything interconnected, which is more or less our technical wish. So we came with the approach that not to go from a top-down approach as you have in a big solutions. We came with the idea from bottom-up approach. So interconnecting small ecosystems into the interconnected environment, which is more or less. I will use a Pareto explanation as a Facebook of devices and services, where based on the interoperability, the devices from different domains can provide a data, can provide a controllability to the other services or to the other ecosystems. As for example, in this example, in this slide, we have on the left side, we have an intelligent building operated by Actor One, for example, which they have own building IoT ecosystem. On the right side, we have the orange one, which is the energy ecosystem. And the energy ecosystem includes PVs, batteries, wind turbines, for example. And the left side, on the blue one, we have some building, which measurement of the data. We have a car, which is owned by someone who is living in a bulk of flats, and we have a charging stations. And this is perfect because you can really in this ecosystem do a lot of stuff. However, for example, for energy ecosystem, for example, for DSO, it is really important to get more information in these days, more information from your building to use, for example, information about the usage of your car, about the load, actual load in the building, to better predict the load of the whole infrastructure, or as well to use your, for example, energy in the car to charge in with the grid services, etc. And as well, the other way around, someone from the building management would like to use energy from the PV, which is for example, installed close to the building or on the other side of the street. Or they would like to have fast charging, which doesn't burn down the infrastructure. They would like to use more or less some virtual battery from energy ecosystem. And we started with this idea, and we find out we can create one platform, which is called Vicinity One, which can interconnect this ecosystem. And what does it mean, integrating the ecosystem? It means to create a connection, peer-to-peer network between these devices, in one interoperable way. This interoperable way means that you can see, you can access, or you can read data, or you can control some devices based on the device type, not the vendor type. That is for us the semantic interoperability. And thanks to this peer-to-peer network created from these devices as well creates, I would say, the quotation mark, a space or environment of accessibility for all devices in the same way. And this enables us to use value-added services which are running on top of this platform, which can access regardless of the technology, regardless of the domain, devices, and create really cross-domain value-added services which brings more value to usage of the device. All this part of interoperability is controlled by the Vicinity, which has several parts. And if you would like to connect your ecosystem to the Vicinity, you need to connect your ecosystem to some time of Vicinity node, which is the logical. I will go to that details later on. So you will connect your you connect your ecosystems to the Vicinity node. We have some Vicinity cloud, which doing the interconnection and setups the information that I would like to share my device to this ecosystem. I would like to share my data to this value-added service, or I would like to register the value system in a Vicinity that it can be that it can access the devices, or I would like to register my devices to the Vicinity so they can be shared and can be visible. So this is the middle part of the whole Vicinity, and I can go into that details. What does it mean? So we have basically two main components, two main big components in the Vicinity. In the middle, you can see on the top of on the north bound, you can see the Vicinity cloud. Vicinity cloud includes a component, is a software component which includes the basic information, and that's the basic information about the service which is registered in the Vicinity. Basic information, I mean profile information about the device. So this is the device, this is the smart plug which has which provides, for example, the current energy usage or cumulative energy, etc., etc. So some description of the device as well as description of the service. You can if you would like to register a device, you need to register in as well in this Vicinity cloud where we store your basic information. That means your email address and nothing too much personal, but basic information to access the cloud and manage the devices. You are registered there. Or as a service provider, you need to register yourself in the cloud so you can register the services there and you can manage all your services and access to the data to the access to the data from the devices by the particular service. So all the management thing of the communication between devices and services and their registration is a part of the cloud. We are not storing, we have several storages there, but we are not storing the actual user data in the cloud. They are not accessible in any cloud-based dashboard. All the information between or from the devices and from the services are stored directly in the IoT infrastructures on the southbound or in the value-added services which you have on the left side. Vicinity Cloud only controls the information flow between inside the peer-to-peer network and information flow between from the IoT infrastructure, so between the devices or from the devices up to the services. And each IoT infrastructure or the device or each Vicinity value-added service needs to be connected somehow to the peer-to-peer network. So that's the second component we are talking about, is the Vicinity node. Actually, when we will go through that implementation of a value-added service, but basically what you need to do is to connect your value-added service to the Vicinity peer-to-peer network using the Vicinity node APIs, I would say. We go into that details later on in the next slide, but that's all you have to do. All the other stuff is just the user management and clicking on the user environment in the Vicinity Cloud. You can see the example on the right screen top corner over there. So this is the basically concept. We only exchange in a peer-to-peer network with the cloud the basic configuration data. So what is the service about, and and information about the connectivity between the device and the services. But actually, data are transmitted between the Vicinity nodes inside the peer-to-peer network and nodes to the cloud. It's really important to understand. How does this architecture fit in your ecosystem? So in terms of the ecosystem, imagine that, for example, I would like to implement a value-added service, for example, in a public transport. We had one question about that. In a public transport domain, I'll have some ecosystem of the applications and added value services which are running in my server, in my infrastructure, or my rented infrastructure. And this is not a part of the vicinity. This is not running. This is just running in your environment. You just, when you would like to use a value-added service in a vicinity, or provide a value-added service for the vicinity, you have to select something from your ecosystem. For example, I would like to have, I would like to provide an added value service which gives aggregated information about public transport in my town, Bratislava, for example. So I will need to implement that. I will need to integrate that value-added service to the vicinity node, and that vicinity through the vicinity to the vicinity. So not hold my only value-added service, and through that vicinity though, I can collect the IoT data information about the usage of the public transport from my location, for example, from the Bratislava. But it's necessary that this information is already integrated in a vicinity. That's the case. So that's the important thing from this slide. It is that your ecosystem actually outside of the vicinity, and you are using, for example, in the value added, you are using from different IoT first, a different ecosystem, the data which you get to your value added service which you provided to the end users. I was talking about the one thing what you have to do is to implement the vicinity node. And the vicinity node is something what should locate somewhere in your infrastructure, and it's the logical part, small logical software component. For this case of value-added services, you only need to communicate directly with the Vicinity Gateway API, which is a small software component running a Java-based application. And I will recommend to use Java HJDK environment and run it on the Linux. So this small gateway API is a small library which provides the REST API of the set of the services for the search, registering devices, services, and requesting a data of the properties of the device. For example, give me the actual value of the energy consumption, or turn on, turn off the smart plug, for example, or just registration to the events which are generated, for example, by the environment smart meter, which generates even when the CO2 level is too high or too low, and this can be processed by a value-added service. So that's the thing what you have to do. This small Vicinity Gateway API, which is able to running as a service, is directly maintains for you the communication with the peer-to-peer network. So you don't need to take care about the other stuff inside. As well, then it as well communicates to the Vicinity Cloud to ensure that you have the right to access the device, you have the right to access and to perform the actions on the device in terms of the service. Or in case you decided as well during this open call, provide some parts of your IoT infrastructure, it as well takes account, ensures that when you provide the data will not be provided to someone else who has no rights for that. This is really important. So that's the privacy of security which is taking place. Your value-added service connected to Vicinity Gateway API, so there is API. The question is where your value-added service can run. It can run directly in the same machine. It depends how you implement it. If it is running in a cloud or it's running locally in your IoT infrastructure. So that was the amazing architecture. When I was talking about what you have to do, this is the set of the links. You will see it in as well. You have it as well in the technical documentation through the second open call. I suggest to go through these 6 links. The first 2 are the Vicinity Getting Started Guide, when we explain the architecture, when we explain how to use a neighborhood manager, when we explain how to use a gateway API, and we explain how to we have small, easy how to getting started. So how to install, how to set up the basic configuration, how to use an agent, how to register the device, etc. So this is this should be your getting started guide to use it. It is possible to run the getting started by someone who is totally outside from the project. We already tested last week. Then we have several documentation on how to use a neighborhood manager to set up the configuration of the neighborhood and visibilities, and as well the documentation of the agent if you would like to decide to integrate as well the device. For the vicinity set of APIs, when you will implement the integration of value-added service, please bear in mind the Vicinity Gateway API, which is the Swagger documentation of the interface. Then Vicinity Neighborhood Manager API. This is optional thing. If you decide that you would like to have we provide as well on the side of the Neighborhood Manager all the most of the functionalities for registering devices, services, creating contracts between devices, all the privacy features of the Neighborhood Manager for setting up your virtual neighborhood. This is optional thing. You don't need to have. You don't have to use it. You can use it. You don't have to use it. And if you decide to integrate as well the devices, it is necessary to go through as well the Swagger of the Vicinity adapter version 1.0. So it gives you more detailed information, the technical one. And the last, sorry to be too long, last message is what you have to do when you would like to connect the value-added service. So first of all, you need to register in the Vicinity Neighborhood Manager as a service provider. That means you implementing a value service, you have to register, because then when you create your organization in the Neighborhood Manager, you are able to register afterwards a service itself. So then you can use register of the service through the Vicinity or the Gateway API, especially the Gateway is cool. Then if you decide that you would like to have as well some devices connected to them for your evaluation or inside of the project, you need to connect the devices as well. This is the optional part, and if you would like to do so, please refer to the documentation of the first open call. There is a guide how to do that. And when you have your service implemented and registered and integrated to the Gateway APIs, then you just don't need to create a contract between devices and services. So if your service is running data analytics tool for the households, which we collect the data about the PV production and energy consumption, you can provide the service, but you need to have the actual device contracts to the devices which are already integrated in Vicinity. And then you can collect the data. So you need to get access to, you need to have a collaboration with the data provider here. And when you have data contracts created, then you can start to process the data, emails, and perform actions on the devices. For the Vicinity open calls, we provide full support from the consortium. So while we have some tools for Q&A, I think Carmen will talk later on that about when you are preparing the proposal, and for the winners during the whole process of the writing a documentation, integration, and implementation of value-added service, we will give you support in terms of how to integrate to the API if there are some open questions that has a problem. So I get you, hopefully I give you a brief understanding of what Vicinity is about, what is the architecture about, what is the value-added service from the technical point of view, how it communicates with the peer-to-peer network for the Vicinity node, that we are not storing the data and you have to store the data collected from the devices in the value-added service, and that you need to use documentation of the gateway APIs to connect to the Vicinity, and these gateway APIs, this Vicinity gateway API is running in a Java 8 JDK, so it's best way to do it that way. And as well, I suggest to recommend it to use and run on the Raspberry Pi. So that's all from my side, and I think we can have, if we have some questions, I will give you word to you back, Carmen.
Many thanks, Victor. Yes, we have several questions. The first one is, do you rely on standards to provide IoT interoperability? I think Maria Coulthry from FAIR can answer this question. Maria, please.
Yes. Well, since we're talking about semantic interoperability, basically in Vicinity, we use and extend actually the W3C Web of Things standard, which enables also interoperability between IoT platforms and also gives a way to describe the interfaces, the APIs of devices and services. So we took this as a standard, and of course we have extended it in order to use it in the project and cover as many cases as possible.
Okay, we have, I hope this can answer your question. Following one, the neighborhood manager API is needed for registering the value of the services. I think Victor is willing to answer this question.
Yes, sure. Thank you. Thank you very much. Good question, George. Actually, the VICINITY Neighborhood Manager API, no. You have to use, for registering the devices and services, you always have to use the Gateway API. The neighborhood, and then you can see the registered device and services directly in the user interface of Neighborhood Manager. However, why you would like to use the API? If, for example, your value-added service provides a full functionality for your customers, in terms means that you building, you have the user management, you would like to, you would like to support the full functionality of IoT the customers, the registering of the devices, services, and controlling of the data, etc. You can use the Vicinity API to do that. Directly from your value-added service. So if you would like to have, for example, for this project, you have something simple, a smaller, for example, just providing some audit log or audit report based on the data collecting from devices. I would like to have something which is a simple one-page value-added service. You don't need to use the API. You can redirect your customers directly to the neighborhood manager. They need to have already registered devices there, and they can give you a consent, or I would say the contract, process the data directly to the neighborhood manager, and you don't need to use the API. API is really just for the automatic things. That's all.
For the following question, where we can find information about type, number of devices installed in your smart home building pilot. Okay. For this question, we want to say to you that you can go for deliverables. Let me see if they are public. Yes. For example, in deliverable 5.1, which is public, and there is in the Vicinity site, you can find the services.
Sorry, Carmen, if yes. I may say that regarding the infrastructure, the devices, the main deliverable is the deliverable 7.1, and there each pilot site describes the infrastructure, so the sensors and devices that uses for the pilot site. And for the services of the pilot site is, as you said, the deliverable 5.1.
Okay, but we should confirm if deliverable 7.1 is public, because 5.1 is public. I'm not sure about 7.1. We can confirm right now. Let me check. Okay, in the meantime, Victor is going to answer Adam Kapala's question right now.
Okay, there was a question from Adam where the IoT interoperability resides, if it is on directly on the devices or not. Actually, the IoT interoperability is done on the level of the Vicinity Gateway API. So in that case, we are independent from the vendors, and that means that really you can, for example, integrate one type of the PV in one of the IoT infrastructure. For example, in one house, you can have several different vendors, and we are still interoperable based on they are able to connect to the Vicinity. So we, yeah, so it's more or less on the level of the Gateway API. But still, for that interoperability, we need to have for specific technology like PV from PV vendor to create a specific adapter to able that to make that device available or Vicinity enabled. And that was the part of the first open call.
Thank you, Victor.
Okay, I must say that deliverable 7.1 is public. It's not on the website, but we will upload it as soon as possible to the website. Or at least I can find. Okay. I don't know if we don't have any more questions. Okay, we are going to upload the deliverable 7.1, and we will let you know by email. Okay. And the following presentation is for Maria Kotli.
Yes, hello. I will share my
Maria,
screen.
from there. She's going to explain us how to create various services. Thank you, Maria.
Hello, everyone. It's Kutli Maria from CERF Research Institute, and I will give a short presentation about how to create a service in Vicinity. So basically, how also to integrate your services into Vicinity. So first, we'll give you an overview of the platform and what can offer to your service, and then I will go into more detail on how to integrate your service into three basic steps, and give you basically the workflow for this. So let's assume you're the IoT service provider. You have an idea for combining data from IoT devices and sensors, which are probably from different vendors. What Vicinity can offer to you. So Vicinity IoT platform can offer to you IoT semantic interoperability, as we have mentioned also before. So it gives you the opportunity to express your sensors and devices in a common language, even if they're not from the same vendor. It can also provide you with peer-to-peer communication and privacy. As it was explained, the data are shared to only the services that have this privilege, that have this contract with a specific device. Moreover, in Vicinity, we have the possibility to also integrate external APIs as value-added services, and you can also combine sensor data with external APIs, for example, for weather data. And also, it could be a place where you could possibly find new clients with IoT infrastructures. Of course, it could be a service that is related and takes data to your infrastructure, but you could also use other infrastructures as also the pilot sites, as we have mentioned before. So, how to integrate into Vicinity? The first step is also, as Victor has said, you will have to integrate your organization. So, register your organization into the Vicinity IoT platform. This is the neighborhood manager that Victor has mentioned, and that is the first step to give some information about your organization and register it into the platform. And the second step would be to download from GitHub repository, since the components are open source, the two main components that will be needed for the infrastructure of the service. So together with the service, you will need to configure and run the Vicinity Gateway API and Vicinity Agent, which are two components which can be downloaded in your Linux machine, locally or in the cloud, as Victor has said. And they need to be running so that they will give you the access to the Vicinity peer-to-peer network and to the communication with other IoT devices in Vicinity. So, apart from these two first steps, what I will need to do in order to integrate my service into Vicinity. And there are three things that you will need to do. First, you will need to create a Vicinity adapter. This is similar to what we're doing also for devices. And it's a way of expressing the functionality of the service to Vicinity. I will give more details about this. Second step, you will need to describe formally your service in the common language and format that we have said before, also and provide it into Vicinity. And the third step would be to make interactions with other sensors from other IoT infrastructures, also through the peer-to-peer network of Vicinity. So we can go into detail now for each of the three steps. So, first step, the creation of a Vicinity adapter. This can be standalone, a web service, or it can be integrated to your service. And what does this mean? What does this will provide to your service? In the common language and format that we use in Vicinity, both for devices and services, we use some interaction patterns, we call them. So a service or a device can have properties, actions, or events, which are basically the translation of the endpoints of the interfaces that a device or a service provides. And this will need to be in a format that Vicinity supports. So first thing that your adapter does is to give this common format to all the interfaces, all the endpoints of your service. The second thing is that it provides a link to the next component, which is Vicinity Agent, which handles the registration of your service in this case. So the adapter will need to provide this description to the agent so that the agent then register the service into Vicinity platform automatically. So this is the part in the red circle that you're mostly interested in, which is basically the service, the business logic of your service, and the Vicinity adapter, which is going to give you an access to the registration and to the communication through the peer-to-peer network. The second step we have mentioned is about the description of the service, formal description. As we have said before, we use an extension of the Web of Things language, which is also uses this terminology. Basically, service and devices are considered as things, and formally they are said to provide a thing description. So it's quite straightforward, since the description is in JSON, which is quite common, and it has a basic structure and schema which you will need to follow. The description contains also mappings to the Vicinity ontology, and I have also put the link here, which if you're familiar with, can give you a better view of the types of devices that it supports and the types of functionalities of properties of the devices or services it also supports. And of course, as we said in the previous step, you will need to provide distinct description to the next component, to the agent. This is an example of a thing description. As you can see, it is in JSON. You have to provide information as the name of the service. In this case, it is a service for power consumption, the version, some ID, and in the red circle, it is the mappings with the ontology. So we have to define the type of this thing. In this case, it is not a device, but it is a service. And also define the main properties that this thing exposes to Vicinity. So in this case, for example, this service might gather information from power meters and calculate the mean power consumption and provide this to the end user. So for each property, we have the description of the endpoint and also the description of the inputs or outputs the service will need to have. Next step, the third step, is the communication with other IoT sensors through Vicinity. Probably you will create a service which will need to read data from other devices or services. So in order to do this, you will first need to be authorized. For this authorization, you will need to create a contract through the Vicinity Neighborhood Manager that Victor has mentioned in the previous presentation, and have this contract between your service and the desired devices. I have also put a small screenshot from a contract, as you can see it in the Neighborhood Manager web interface. Next step, if you establish this contract, you will need to make a specific call to this object in order to get its data. Of course, in the Neighborhood Manager interface, you can see the specific characteristics of this device, what properties it exposes, what you can ask, and what you will need to do in order to form this request is to first, you will need to contact the agent, which is the next component after Vicinity Adapter, and also provide the specific endpoint for this resource with also by giving also the let's say IDs of your service. So this is quite simple, I think. And finally, that's the basic workflow for integration of a service into Vicinity. So the first two steps, which are quite general, either you have a service or a device, it's same. You will need to register an organization, and you will need to download from GitHub and configure and run the two Vicinity components in your local machine or in the cloud. And then specifically for your service, you will need to expose your service through a Vicinity adapter. So adapt your endpoints, describe the offered functionalities of your service, and make contracts with other sensors so that your service can have the ability to get data from them. So then it's easy, you can start programming the internal logic of your service. That is all. If you have any questions.
Thank you, Maria, for your
Thank you also
for your presentation. Yes, we have here a question from Michael Jacobi. Is that can custom ontologies be used to describe a service metadata, e.g., service type, units of measurement, or only the Vicinity ontology?
sorry, just to understand the question.
Yes.
A service description can be used also to describe services metadata. For example, it can also you can also provide I think this information. I'm sure for the device, but I suppose it is similar also for the services. But in order to reply in detail, I will need to see the specific fields of the ontology in order to say which are the metadata we support. But of course, ontology provides also metadata for each service, apart from the functional, of course, characteristics.
Thank you, Mary. I will add a bit of more information on that. Actually, if you would like to, we are using the Vicinity ontology in semantic interoperability inside of the Vicinity peer-to-peer network data exchange. If you would like to have more, see what information we are providing in input documents for the for this OpenCode, you can find the link to the actual ontology, so we can see the ontology inside of the Vicinity. If you think that you will need to have some more measurements, some more specific data, more properties which are not defined in ontology, and you would like to, for example, provide it inside as a microservice inside the peer-to-peer network, of course, you can define Vicinity ontology requirements during the running of the project, and then we can incorporate that in inside of the Vicinity ontology.
Okay, thank you, Victor, for your answer, and Maria, for your answer and your presentation. We have one question left, but I think I'm going to answer this question during my presentation. Hello again and welcome. My name is Carmen Perea. I work in Atos. I'm going to explain you the participation rules. Okay. First of all, I will try to show you the time framework of the open call. After this, I am going to show you how to apply. And after this, I will explain you about the evaluation process. To finalize explaining you how to get support from the Vicinity team. Okay. As you can see, as you know, I hope right now, we are asking for value-added services and microservices. The proposal will be funded with 60,000 euros as maximum, is one. We expected that the duration of the project will be 5 months as maximum. The open call started on 15th of December 2018, and it will be finished, the call itself, on 15th of March. Then our intention is that the project started in May 2019. If you see this time framework, you can see easier that we are here now in the webinar in the end of January. We will finish the open call on 15th of March. The evaluation will be held from 15th of March to 15th of April. From April to May, we will have the evaluation negotiation, not evaluation negotiation, the negotiation with the applicant or with the winners. And the idea is to start the project on 15th of May, and you will have 5 months to do the project. Okay. As I said before, 60,000 euros per project.
So up to 60,000. Or you can also do it with 30,000.
Okay, thank you, Christoph. This is the place where you can find the open call documents in the website. I keenly recommend you to read carefully this document. You can find there the press release with a summary of the call, technical guidelines. In this document, you can find an overview of the vicinity, architecture, pilots, and the technical requirements. The evaluation criteria. This is a very, very useful document. Please review it, read it, and try to answer the question in the F6S form according to this evaluation criteria. Take this on your mind. Then you will see the guide template in which you can find information about how to apply and the evaluation process. And then the following document is the standard extension of the contract. That this is the document you will sign with the consortium, the contractual document if you win the open call. Take a look only to have ideas about what you are going to sign with us, but it's not relevant for the contest. And the last one is a template you are going to use in the F6S tool. Well, who can apply? If you have a bad number, you are an individual SMEs, large companies, research institutes, and universities. That's some universities have asked me about this. Yes, you can participate. Public authorities as municipalities, regions, ministries, and very important from European member states or associated countries. Okay. A proposal, as we have explained before, should create new specific value-added services based on the Vicinity platform or create new specific microservices to enhance the Vicinity platform. It should cooperate with the Vicinity partners to demonstrate of the OpenCall project results within the duration of the project of the proposed project. And the proposal must explain how the services support existing use cases, services, and or business models in Vicinity or new ones, and or undertake co-creation activities. The evaluation criteria, Christoph is going to explain the evaluation criteria in detail. Christoph, please.
Yes, so already some questions there according to which, sorry, that somehow I hear some noise here. Okay, good. We have set up the evaluation criteria, and the evaluation criteria consist of let's say four major criteria that equally contribute to the overall evaluation. That means we have the benefit of the service you implement for the Vicinity platform. Second, the business model that you describe. This deals in particular with also some sustainability that we expect, that you do not only propose some value-added service that will be implemented for the project and then will die, but we want to see that you have the ambition to sustainably contribute and that there is an underlying business model behind it. The third is the excellence and the soundness of the proposal. We want to see that it is not some service that can be seen 100 times on the globe already. That is, for example, demand-side management. That would not be really new. Yeah, this is a service that, by the way, we have already here and there in the proposal. It should be something excellent, new, and sound. Yeah, sound means we expect that it is in itself logic and that there are no lacks of soundness in the proposal. Last criteria is the capability of the proposer. That means that we want to see you to be capable of implementing this as well. For example, if you describe something to implement in a city and there is a problem that you cannot convince the reviewer that you can access the devices, for example, in the city, or that you are lack the qualifications, or you must describe your qualification and as well the capacities your organization has to implement also what you have described. So that's the three major evaluation criteria.
Okay, many thanks, Christoph. I will continue with my presentation. If we have more questions, we will answer after the presentation. Okay. Well, how is the evaluation process? Once we have the proposal, once we have received the proposal on 15th of March, this proposal will be given to 2 evaluators. These people are going to review the proposal and check it, and they are going to issue 2 individual evaluation reports, 1 and 2, with different marks because everyone has different criteria, and we are managed to have the consensus meeting in which the 2 evaluators should agree on the marks, and they have to issue a new report called consensus report, quite similar to the one you are going to receive. And in this report, you will see the marks you are getting. this process is reviewed and watched for us for the Vicinity Consortium, but is implemented by external evaluators in order to guarantee the bias of the process. Okay. How to apply? I have seen a question, but you are going to use the FCS portal. This portal has been used in several Horizon 2020 open calls. You only have to submit a proposal in this portal, but you are going to use the templates we have provided to upload some information, because there are different kinds of questions. In the portal, we have split the information in these 8 sections: questionnaire, basic info, overview, section 1, 2, 3, 4. As you can see, this matches with the evaluation criteria, and then the last one, miscellaneous, where we asked you some questions in order to know more about you. Well, things to take care of. The answer have limit. If you see here to the right of the answer, you can see the limit of characters you can use. Don't worry, because the system is not going to allow you to put more. Then you have to take into account that if in some question, you should upload information. When you can find this, choose a file, but please take into account what we said here. If we ask it for PDF, please upload a PDF and take into account the size of the file. And even if we say that this section have a limit of 3-4 pages, please take into account this limit and don't exceed the limit. More things. When you are going to fill the questionnaire in the tool FCS, you have to indicate in which topic you are going to participate. You have to choose between topic A or topic B. You can here is a radio button, and you have to select between topic A or topic B. Requirements. You have to select in which requirement you are going to submit your proposal. Yes, you only can select one, and you should take care that this selection matches with your selection on topic A or topic B. Here you can see the 13 topic A requirements, and below you can see the 4 microservice requirements, topic B. Okay, take care and please match. But if you think that your proposal can cover one of the more than one requirement, you can indicate this in the following question, in question 11. But in this, you have to select the main one. Okay. Common errors. Please read the documentation carefully. For example, in the last call, for a question similar to the 27, work package, work plan, and deliverables list, this is the template we have provided to you. We have insist in the content of the deliverables. If we say that the deliverables should contain a data management plan, evaluation plan, exploitation and business model, please mention this in your proposal and explain how you are going to do it, because we have found in the other proposal that people don't take into account this, and this is going to it's going to mean less point for you and less rank. Okay. And after this, I have to say that we are using several channels for communication with you, but for us, the main communication channel is the email, the open calls at Vicinity 2020 EU. We are checking this email daily, looking for your questions. Once we receive a question, we answer the question, we will publish all the questions and answers in the Vicinity page in the frequent asked questions. And feel free to contact us and ask for whoever you need. Okay, whatever you need, please. And to finalize, we will communicate with you using the newsletter, the open call newsletter. And if we have some relevant information to provide you, we will do on the website, on Twitter, and by email. And that's all from my side. You have here the Twitter, the Vicinity web page, the LinkedIn, and the email we are using to support you. Okay, this is the end of my presentation. I'm going to check for questions. I suppose that the time frame is answered. Yeah, this question. The question between yours in the template, there is only the implementation part, but it seems the other settings are needed. Yes, you can find this in the FCS web. You can find the sections. Also, there is a document called walkthrough, FCS walkthrough, in which you can find information about the system FCS here. This one. In this one, you can find the content of the IFCS system, and you can find what question we are asking. We have another question from Rehan Herzog. Does benefit for Vicinity mean that the service needs to be used by some use case? Well, not mainly by some use case, but you have to demonstrate that your service is useful. And if you find if you check the evaluation criteria, you can find what questions you have to answer about this. For example, I'm going to open the document. Let me open the document right now. You see here, you have to explain how is this service relevant for Vicinity. For example, are these services you are going to propose is supporting existing or new use cases, services? How large is the benefit for the customer? How large is the benefit for the society, environment? And you are going to, the evaluators are going to rank the quality of your co-creation plan. More questions. I hope I have answered your questions. what is the difference between 1 and 4 in the mandatory deliverables list? Okay. Oh. Test plan and test implementation, and 5 evaluation plan. Okay, the difference is here you are providing information about how you're going to test your features, the software you are implementing, and for me the evaluation is something more bigger, and you have to demonstrate how you are going to evaluate your project, the overall project, not only the test cases that are implementing the software. A question for David Carro. Are the slides going to be available on the Vicinity website? Yes. Rehan Herson say, are there any license requirement for the offerer service? Victor, I think, is going to ask this question.
Yes, thank you, Carmen. Actually, the main requirement, license requirement, is that we should be able to at least run the value-added service for the period of the project. It means the open call project, and as well doing the validation, etc. But bearing in mind that the licensing requirements is as well needs to be taken account from the point of view of exploitation possibilities of the service. If your license is too restrict, or in terms of the usage, or in terms of the fees, etc., it can slow down the exploitation of your value-added service. So this is upon you, but at least it should. This is the same thing as during the project. We provide free of the charge access to the platform and use it by the service. So we expect as well during the running of the project, validation, we don't need to have any license for that. This is maybe my response to your question.
Okay, thank you, Victor. And I must say, for the last question from George, yes, you are right. If we should rewrite this one intermediate and final technical and management report. What is the difference between final and technical and management information? Well, we mean that you have to deliver at least 2 deliverables, intermediate and management report, with this information, final, technical, and management information. We should rewrite this part of the question, and we come back to you with more specific instruction about this. But you are right, we should check this. But at the end, what you have to do is to have at least 2 reports, intermediate and final, and with this information, technical and management information. Okay, well, I hope you have found this webinar useful, and we have been able to clarify you all your doubts. We will try to upload this question you have asked us in the frequent asked questions, and we will try to clarify if something is not really clear. Please, we ask you, if you want to ask again for some question, please use the email and send us whatever you think is necessary to clarify. Use this email, opencalls@vicinity2020.eu, and I think all questions are answered right now. Christoph, do you want to close the webinar?
Yeah, if there are no further questions, I would like to thank everybody for the interest in our open call. So, yeah, if there are further questions, don't hesitate to contact us. Many thanks for joining, and goodbye.